Okay, hello, grade 11 students. For this session, we are going to talk about organic compounds. So let me share my screen. Okay, so what are organic compounds? So organic compounds apply to all carbon-containing compounds, with the primary exceptions of carbon oxides, carbides, and carbonates. So these are compounds containing carbon and mainly comes from living things. Alcohol, we have oil, petroleum products. Okay, these are examples of organic compounds. So for carbon, so why carbon is so special, okay, among the list of elements or atoms. So it forms 4 covalent bond. It bonds to hydrogen atom in element near it, bond to other carbon atoms, and form chains from 2 to thousands of carbon atoms. So they form a complex, a branch chain, ring, and even cage-like structures like this. Okay, so for organic compounds, we represent them in their structural formula. So you can make use of the molecular formula, the condensed structural formula, the expanded structural formula, and the skeletal formula or line angle formula. Okay, like this. So for organic compounds, you may make use of the structural formula of the compound, line diagram and skeletal, and the condense. Okay. For the classification of organic, so we have hydrocarbons. So what are hydrocarbons? So these are compounds containing hydrogen and carbon. Okay, best example for this is methane. So you see here methane, the element carbon, and the element hydrogen. So this is the simplest hydrocarbon. Okay. So for multiple carbon-carbon bonds, so carbon can bind with another carbon. So for multiple carbon-carbon bonds, we have saturated. Here, we'll see single bond in their structural formula, or only single bond is present in their structure. For unsaturated, it's double and triple band. So take note, in covalent bonding, we talk about single band, double band, and triple band. So for single band is for unsaturated, unsaturated is double and triple band. Okay, so for that single band, we had, for saturated, we have alkanes. Okay, what are alkanes? Okay, so alkenes are hydrocarbons that have only single bond between atoms. And its formula is CnH2n plus 2. Okay, single bond for carbon and hydrogen. So this is the member of the first 10 alkane series. Okay, so take note of the family of the first 10 of the alkane series. So we have methane, ethane, propane, butane, then pentane, okay, from penta, hexane, no, heptane, octane, nonane, and decane. So this is the molecular formula of this alkane and its condensed. Okay, so in naming a straight chain alkane, so these are straight chain alkanes, and we are going to name them using their name. Like this one, CH4, the name is methane. This is the structural formula, it's ethane, so it's a straight chain. Okay, so in naming, we simply identify the first 10 alkane series. Okay, what about the branch chain alkane? So you will see in these examples that the hydrogen is actually replaced by a substitute, not a substituent. Okay, and in naming, we cannot just simply name them as butane. You will see here that the longest carbon chain is 4, and this is actually butane, but because of the presence of the substituent, you can't name that as butane. So how are we going to name them systematically? So for branch chain alkanes, we need to identify the parent chain and the substituent. So what do I mean by parent chain? So parent chain is the longest continuous chain of carbon atoms. And the substituent appear to substitute for a hydrogen atom in the straight chain. So the hydrogen is actually replaced, okay, by this substituent group. Okay. So that substituent is actually called alkyl groups. Okay, so what are these alkyl groups? So this is a piece of molecule with the formula CnH2n plus 1. Okay, so take note in alkane, it's CnH2n plus 2. So this is CnH2n plus 1. And so for methane, we have methyl, ethyl, propyl. So it ends in YL. Okay, so methane, the alkyl is methyl, ethane is ethyl, propane is propyl, butane is butyl, and so on. Okay, so in naming, let's have first the guidelines in naming branch chain alkane. So first, count the number of carbon atoms in the longest continuous chain. Use the name of the straight chain alkane with the number of carbons as the name of the parent chain structure. So that will be your parent chain. So count the number of carbon atoms in the longest continuous chain. That will serve as the parent. And then you number each carbon in the parent chain. Locate the end of the carbon closest to a substituent group. Label it as carbon 1. Okay, so in numbering the parent chain, you start with the end closest to the substituent. The third, name each alkyl group substituent. Place the name of the group before the name of the parent. So you have to name first the substituent before the parent chain. If the alkyl group occur more than once as a branch, then use prefixes such as di, say dimethyl, trimethyl, okay, tetrabutyl, before its name to indicate how many times it appears. Then use the number of the carbon to which each is attached to indicate its position. Okay. And then when the different alkyl groups are attached to the same parent structure, place their names in alphabetical order. Do not consider the prefixes when determining alphabetical order. Okay, so again, the substituents are alphabetized, disregarding the prefixes. Write the name using hyphen to separate number and comma, number and word, and comma to separate number and number. Okay, so, okay, let's check from this example. Okay, so this will be the parent. Okay, so these are substituents. So number in a way that you start at the end, no, closest to the substituent. So obviously you are going to start numbering here. Okay, so this will be number 1 carbon, number 2, 3, and so on. So this substituent is methyl, so there are two, right? So you have two methyl is dimethyl, and it falls on number 3 and 5. And number 4, you have ethyl. So take note, it's alphabetized. So it's 4-ethyl, 3,5-dimethyl, and then the parent is octane. Okay? So 4, take note of how it is written. The number, the hyphen, is to be used not to separate number from word, and then comma, number and number. So it's named as 4-ethyl, 3, 5-dimethyl octane. Okay. So we also have cycloalkanes. Okay, what about cycloalkanes? So this is a cyclic hydrocarbons that contain only single bond. Take note, alkane, saturated, containing single bond. Can have 3, 4, 5, 6, or even more carbon atoms. So these are our examples of cycloalkane. Okay, cyclo. Okay, so you have cyclopropane, cyclobutane, cyclopentane, cyclohexane. Okay, so how are we going to name cycloalkane? So for example, this is the example. Okay, so in naming substituted cycloalkane, no need to find the longest chain. Why? Because the ring is always considered as the parent chain. Okay, if it is propane or butane or pentane, so it's the ring. Numbering is started on the carbon that is bonded to the substituent. Take note that numbering of the carbon will start on the substituent group. But take note, when there are 2 or more substituents, the carbons are numbered around the ring in a way that gives the lowest possible set of numbers for the substituent. Okay? So say, for example, how are we going to name this? Okay? So in naming, count the carbons in the ring and use the name of the parent cyclic hydrocarbons. Number the ring starting from 1 of, take note, the substituent methyl branches. Find the lowest numbering that gives the lowest possible set of numbers for the branches. Name the substituent, add the prefix to show the number of groups present, and alphabetical order can be ignored if there is only one type of group is present. So, but if there is more than one, you have to alphabetize. Put the name together using the name of the parent cycloalkane. Again, use comma to separate numbers and hyphen between numbers and words. Okay, so how are we going to name this? So numbering. Okay, so take note, 1, 2, 3, 4, 5, 6. So this is cyclohexane. That's the parent. But you look at the substituent, so you have to number this in a way that will give you the lowest possible set of numbers. So this is 1, 2, 3, 4. Instead of 1, 2, 3, 4. So it's 1, 4, 5. 1, 2, 3, 4. So it's 1, 2, 4. So there are 3. So you have to make use of tri-methyl and then cyclohexane. So it's 1, 2, 4. So 1, 2, 4 hyphen trimethyl. Then the parent is cyclohexane. Okay, moving on, we'll now have alkenes. What about alkenes? So this is an example of unsaturated hydrocarbons that contain one or more double covalent bonds between carbon atoms in a chain. So take note of the presence of double covalent bond. Okay, and its formula is CnH2n. Okay, so if there are 2 carbons, there will be 4 hydrogen. So it's C2H4, C3H6, right? So that's for alkenes. Okay, so these are our examples, no? Okay, ethene, take note of how the name ends. ENE, ethene, propene, butene, okay, butene, pentene, hexene, heptene. So that's for alkenes. How are we going to name alkenes? You notice the ending, no? From ANE for alkane, it's now ENE. So specify the location of the double bond, then number the carbons in the parent chain starting at the end of the chain that will give the first carbon in the double bond, the lowest number, and use that number in the name. Take note, the numbering, it's about the presence of the double bond. So in naming branch chain alkenes, the parent chain is always the longest chain that contains the double bond. The position of the double bond, not the branches, determines how the chain is numbered. Again, the position of the double bond, not the branches. Unlike in alkane, it's the position of the substituent. Determines how the chain is numbered. Okay, so for example, okay, so you look at this one, the position of the, okay, let's have the position of the double bond, 1, 2. So the parent chain is 1, 2, 3, 4, 5, 6. The double bond falls in number 2. So it's named as, okay, 2-hexene. 2, and then the parent is hexene. Okay, what about this? So, okay, same, 1, 2, 3, 1, 2, 3. So you may number here, 1, 2, 3. So 3, the parent is 1, 2, 3, 4, 5, 6. So it's 3-hexene. But take note of the substituent here, the branch chain alkene. So it's 1, 2, 3. So it's trimethyl, and the numbers are 2, 2, and 4. So it's named as 2, 2, 4 hyphen trimethyl hyphen 3 hyphen hexene. Okay, so it's the position of the double bond. Take note of that. Okay, in naming cyclic alkanes, okay, carbon number 1 must be one of the carbons connected by the double bond. Take note that the numbering, okay, starts from the carbon with the double bond. So it's 1, 2. So 1, you have 1, and then the substituent is methyl, and then it's cyclohexene. Take note, hexene, cyclohexene. Here, numbering starts from here. So you have 3-methyl and then cyclohexene. Okay, so that's for naming cyclic alkenes. What about alkynes? Okay, so unsaturated hydrocarbons that contain one or more triple bond between carbon atoms in a chain. So this time, you will see the presence of triple bond. And its formula is CnH2n minus 2. Okay, so it's C2H2. Okay, and that is the simplest example for this is ethine with the formula C2H2. So our general formula for alkynes is CnH2n minus 2. And these are our examples of alkynes. Ethine, propyne, butane, pentine, hexine. So take note of the name, the ending for alkynes. Okay, so in naming alkynes, straight chain alkynes and branch chain alkynes are named in the same way as the alkenes. The only difference is that the name of the parent chain ends in Y and E. So same system as the alkene, and then the only exception is that the only difference is the ending Y and E. Okay, look at this. So numbering will start on the presence of the triple bond. So this is 1. And then you will see 1, 2, 3. So there are 2. There are 3, 3 hyphen dimethyl hyphen 1 hyphen butane. Okay, so 1, 2, 3. So that's 3. 1, 2, 3, 4, 5, 6, 7. So it's heptine. But you look at the substituent. So you have 5-ethyl, so alphabetized, no? 5-ethyl, then number 2, you'll find the methyl, and then the number 3, and then the parent is heptine. Okay, same as with this example. So it's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so you may start numbering here. So you'll find here in number 4, ethyl, in number 7, methyl, and then the triple bond falls on number 5, and then the parent is decyne. So this is how to name this structure. Okay, what about this? So this is the triple bond is on the 3rd, but you will see a methyl on number 7. So this is 7-methyl, 3, and then the parent is octane. Okay, and this one is 1 here. Okay, that's 1 pentine. Okay, so this is how we're going to name alkynes. Okay, moving on, we have also to consider how to recognize and name aromatic hydrocarbons. Okay, what about aromatic hydrocarbons? So again, aromatic hydrocarbons, again, it has carbon and hydrogen. Okay, but how is this different from alkenes, alkene, and alkynes? So aromatic hydrocarbons are usually stable compounds with ring structure in which electrons are shared by many atoms. So the identity for aromatic hydrocarbon is the benzene. So it was proposed by Michael Faraday, okay, with a formula of C6H6. And this is how it looks like. Okay, so you see here the structure of benzene. So Friedrich Kekule, okay, proposed a hexagon. Now proposed a structure of benzene, and that's a hexagon of carbon atoms with alternating single and double. Okay, so this is how the proposal of Friedrich Kekule on the structure of benzene. And Linus Pauling for the modern model of benzene proposed the hybrid orbitals, and this is how benzene looks like. Okay, so this identify aromatic hydrocarbons, the presence of benzene. And how are we going to name aromatic compounds? Okay, so aromatic compounds are organic compounds that contain benzene rings as part of their structure. Okay, so that's the benzene ring. How are we going to name substituted aromatic compounds? So name in the same way as cyclic alkenes is named. Substituted benzene rings are numbered in a way that gives the lowest possible numbers for the substituent. Okay, like this one. So you number it is a 1, 2, 3. So that's the lowest number, right? So you have 2, 1, and 3. So 1, 3, then hyphen, diethyl, and then the parent is benzene. Okay. So here you have propyl benzene. And for this example, you have K1 methyl, we have 4, propyl, and then benzene. So you see 1-methyl, -4, -propyl, and then benzene. So again, benzene defines aromatic hydrocarbons. Okay, so clarifications. So thank you for watching. I hope you learned something from this discussion. Okay, see you in our next session.